Introduction. If we raise a body above the ground and then release it, the body falls down towards the earth due to the force which must be acting on it. The force acts due to force of attraction between the earth and the body, which is called force of gravity. As per the example, the ball thrown upward will fall downwards due to gravitational pull or force of gravitation. Gravitation causes variation of weight of a body, varies from place to place. This would be well understood by studying gravitational phenomenon. Objectives. At the end of this lesson, you'll be able to define force of gravitation, define universal law of gravitation, understand the meaning of free fall, distinguish between weight and mass, understand thrust and pressure, understand force of gravitation. The gravitational pull. Everything is pulled downwards towards the earth. The force with which two objects attract each other is called force of gravitation. The force of gravitation acts even if the two objects are not connected to each other. Centripetal force. The force due to which the body moves along the circular path acting towards the center of the earth is called centripetal force. The gravitational force between the sun and the earth keeps the earth in uniform circular motion around the sun. This is the centripetal force which acts between the earth and sun. Universal law of gravitation. Everybody in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Force is directly proportional to the product of their masses. Force is inversely proportional to the square of the distance of separation between the two objects, where g is the universal gravitational constant and the SI unit is Newton. Unit and value of gravitational constant. By arranging the expression for force of gravitation, we have G is equal to F into R square upon M1 into M2. SI unit is Newton meter square per kilogram square or Newton meter square per kg square. The gravitational constant G is equal to the force of gravitation which exists between the two bodies of unit masses kept at a distance from each other. The value of universal gravitational constant is G is equal to 6.67 into 10 raised to the power minus 11 Newton meter square per kg square. Importance of universal law of gravitation. The force binds the earth. The motion of the moon around the sun and the tides due to the moon and the sun. Free fall. Our earth attracts all the objects which are near its surface so that when a body is dropped from the roof of a house, it falls down to the earth. The acceleration produced in the freely falling bodies is the same for all the bodies and it does not depend upon the mass of the falling body. Acceleration due to gravity. The uniform acceleration produced in a freely falling body is due to the gravitational pull of the earth, is called as acceleration due to gravity. The value of acceleration due to the gravity is 9.8 meter per second square. Force is equal to mass into acceleration, which is equal to m into g. Equation 1. Force due to gravitation. F is equal to m into mg upon r square. Equation 2. Where m is the mass of the earth and r is the distance between object and the earth. from equation 1 and 2, m into g is equal to m into mg upon r square. G is equal to gm upon r square. The value of g is g, difference between weight and mass. Mass. The mass of the body is the quantity of matter contained in it. The mass of the body is constant and does not change from place to place. It is denoted by small m. Mass of the body is a measure of inertia of the body. Mass cannot be zero. Weight. The weight of the body is the force with which it is attracted towards the center of the earth. The weight of the body depends upon the mass of the body and acceleration due to gravity at that place. Weight is Newton. 1 kilogram weight is that gravitational force which acts on a body of mass 1 kilogram. Weight is not constant. The weight can be zero at the center of the earth. Equation of motion for freely falling bodies. The three equations of motion of freely falling bodies is given as V is equal to U plus GT, S is equal to UT plus 1 upon 2 GT square, V square is equal to U square plus 2GS. Acceleration due to gravity for free-falling body is plus 9.8 meter per second square. Acceleration due to gravity for a body thrown upwards is minus 9.8 meter per second square.